All right, guys, this is note card 25. It's called vertical tangent lines. So Stacy's notes up here says to find the point or points where a function has a vertical tangent line, find the derivative, and set the denominator of the derivative equal to 0. Okay. And why do we do that? Because the slope, derivative means slope, and the slope of a vertical line has 0 on the bottom because vertical lines have undefined slopes. Solve for x, then substitute that value of x into the original function to find the y value of the point of tangency. So let's jump into some examples so we can see this. Okay, so it says for each of the following, find the point or points, if any, where the relation or the function has any vertical tangent lines. So let's go ahead and rewrite g of x in a way that's easy to take the derivative. So 3 minus, I can rewrite this part as x to the 1/3 power. Okay. Now, let's go ahead and find the derivative of that. Let's find g prime of x. Okay, well, the derivative of a constant is 0, so I don't have to worry about that. The 1/3 comes out front, so I have a negative 1/3, negative because that's a negative, because there's an understood negative 1 there. We reduce the power by 1, so 1/3 minus 1 would be negative 2/3. So that's the derivative. Okay, now let's rewrite this a little bit differently. Let's rewrite it as negative 1 over 3, and let's move this x to the negative 2/3 to the denominator. So it would be written like that. Okay. All right. Now let's write it as a radical. Negative 1 over 3 times the cube root of x squared. Okay. So that's the derivative. Okay. So based on the notes, you just take the denominator and set the denominator equal to 0. Okay, so 3 times the cube root of x squared equals 0. Okay, let's simplify this a little bit. Let's just divide both sides by 3. Okay, so now I have cube root of x squared equals 0 divided by 3 is still 0. How do you undo a cube root? You would cube both sides. And then we would be left with x squared equals 0 cubed is still 0. And how do you find x now? We would take the square root. Don't forget to add the plus or minus there. Right. And the square root of 0 is just 0. So positive 0 or negative 0, they're both 0. So x equals 0 is the x value. But again, we're trying to find the point or points. So now we got to plug this x value back into the original function. So now I have to find out what g of 0 is. So 3 minus the cube root of 0. Well, what is the cube root of 0? It's 0. So 3 minus 0 is 3. So what does that mean? On the original graph at the point 0, 3, that is where I'm going to have a vertical tangent line. Okay, let's actually look at the graph here using Desmos. Okay, here's the graph of that function. And you notice right here at the point 0, 3, it has a vertical tangent line. If I drew in a tangent line right there, it would be completely vertical. It would have an undefined slope, straight up and down. Okay. What does that look like? The vertical tangent line would just be, the equation of that would be x equals 0. Right there. It's a vertical line, x equals 0. Okay, let's try the next one. I'm just showing you the graphs to kind of match up what we're doing calculus-wise with what the graph looks like. So let's rewrite this. Let's rewrite f of x. I can rewrite that as 4 minus x squared. This is a square root, so it's getting raised to the 1/2 power. Haven't taken a derivative yet. Now let's find the derivative. So to find the derivative of this, I'm going to have to use chain rule. The 1/2 would come out front. The parenthesis would stay the same. I would reduce the power by 1. But now I have to multiply times the derivative of that parenthesis. So the derivative of 4 minus x squared, derivative of 4 is 0. And the derivative of negative x squared is negative 2x. So let's rewrite this again. So I have a 1/2. I can move this thing to the denominator times negative 2x over 1. Okay. Well, you got a 2 here and you got a 2 there, so it cancels. Okay. The negative's still there though. So you have a 1 times negative x. That's negative x. Okay. And on the bottom, all you have is this 1 times this thing. But we can rewrite that as simply the square root of 4 minus x squared. So that's what the derivative is. Okay. Now to figure out where the function has a vertical tangent line, we can figure out, set the denominator, just the denominator, this part, equal to 0. So let's take the square root of 4 minus x squared and set it equal to 0. So I'm just trying to figure out where the bottom is 0. Where am I going to have an undefined slope? Okay. So how do you get rid of a square root? You square both sides. So you're left with 4 minus x squared equals 0 squared. 0 squared is 0. Add x squared to both sides. Okay. And then to solve for x, I can take the square root. Don't forget when you do that to put a plus or minus in front of that. Okay. So actually on this one, there's two x values, positive and negative 2. So on this original graph, you got an x value of 2 and you have an x value of negative 2. Okay. Now, how do I find the y values? I'm going to plug these numbers back into the original function. All right, so if I want to figure out what f of 2 is, I'm going to plug in 2 everywhere I see an x. 2 squared is 4. 4 minus 4 is 0. And the square root of 0 is simply 0. So 2, 0 is 1 point. I can do the same thing with negative 2. If I plug in negative 2 here and square it, that's still going to be positive 4. 4 minus 4 is 0 again, and the square root of 0 is 0. So these are the 2 points on the curve where there would be a vertical tangent. So let's see that on Desmos real quick. So I'm just going to say y equals the square root of 4 minus x squared. Okay, so it's a semicircle. And notice right here at negative 2, 0, you would have a vertical tangent line, straight up and down. The equation of that vertical tangent line would be x equals negative 2. Right there. There'd be a vertical tangent line there. And there's also a vertical tangent line right here at 2, 0. And the equation of that vertical line would simply be x equals 2. All right. So now we have a weird curve. It says consider this curve. Now it's not a function, it's an implicit relation. Now it just says find the x coordinate of each point on the curve where the tangent line is vertical. Okay, so I'm actually going to show you that curve first on Desmos. So I have xy squared minus x cubed y equals 6. Funny looking curve. Okay. So we have to figure out where, if any, what points where would I have a vertical tangent line. So to me, maybe about like right there, I might have a vertical tangent line. Maybe that's the only one I kind of see. If I zoom out a little bit, I see any other parts of the graph. That's my initial thought, just right there. Okay, so let's do this out. So first step, take the derivative. So you got to remember how to take derivatives of weird looking stuff, non-functions. Okay, so look at the first term. How do I take the derivative of that? I need to use product rule. So derivative of the first term's x, so the derivative of that is 1 times the second term, y squared, okay, plus the first x times derivative of y squared, which would be 2y, but I need to add in a dy dx. Okay. Now, you could do minus with a parenthesis, but I'm just going to treat, this is another product, look at that. Okay. I'm just going to treat the first term as negative x cubed. So the derivative of negative x cubed is negative 3x squared times the second term y, product rule, so we do a plus, the first term, negative x cubed, the derivative of 1y is just 1, but we need to put in the dy dx on it, because I took a derivative of y. Okay. The derivative of a constant is 0. Right. So if we rearrange some stuff here, let's just kind of rewrite this. I have 1y squared, that's just y squared, plus x times 2y is just 2xy, dy dx. Okay. Then I have a minus 3x squared y. Okay. And then 1 times negative x cubed is negative x cubed, but it has a dy dx on it, equals 0. Okay. Now we gotta, here's the two things with dy dx on it. We got that thing and we got this thing. Okay. The other two terms I want to move to the other side. So I'm going to subtract y squared from both sides and add 3x squared y to both sides. So minus y squared plus 3x squared y. That'll get those to cancel. Okay. Of these other terms, what do they have in common? They have a dy dx in common. Okay. So I'm going to factor that out. And I have 2xy minus x cubed. And on this side I have a negative y squared plus 3x squared y. So if I wanted to solve for dy dx, I would have to divide both sides by 2xy minus x cubed. So divide both sides by 2xy minus x cubed. So that's the derivative. This is the derivative right here. I'm just going to go to a piece of paper. I think I'm going to need a little bit more room. So we have dy dx equals negative y squared plus 3x squared y over 2xy minus x cubed. Now to figure out where we're going to have a vertical tangent line, we take this and set it equal to 0. These things have in common? Well, they have an x in common. They have an x in common. So I could take out an x. So from the zero product property, if either one of these parentheses is equal to 0, then the whole thing equals 0. So this is going to have a vertical tangent line at x equals 0. Okay, set that equal to 0. Now let's set the second one equal to 0. Okay. And let's go ahead and solve this for, we can solve it for y or for x. It's probably going to be easier to solve it for y. So if we add x squared to both sides, and I get that. And if I divide by 2, I get that. But that doesn't give me the x value. Okay? All that tells me is that I'm going to get a vertical tangent line when the y value equals the x squared, the x value squared divided by 2. To figure out what the actual value is, now I have to stick this thing back into the original equation. Okay. So what was the original equation? This was the original equation. Xy squared minus x cubed y equals 6. That was the original equation. So everywhere I see a y, I'm going to plug in this thing. And let's see if that does the trick. So x times y squared, let's plug in what y is, x squared over 2, but don't forget to square it, minus x cubed times y again, that's another x squared over 2, equals 6. So now I can solve this. Okay? So I have x times x squared squared is x to the 4th, 2 squared is 4, okay, minus x cubed times x squared over 2 equals 6, and these x's are x over 1. Okay. So x times x to the 4th is x to the 5th, so x to the 5th over 4 minus x cubed times x squared is another x to the 5th. 1 times 2 is 2, and that equals 6. Okay. We can make this problem a little bit nicer. All right, let's get a common, or let's clear our denominators. Let's multiply every term by 4. That's going to get those to cancel out. So here I have an x to the 5th minus 4 over 2 becomes 2, x to the 5th. 6 times 4 equals 24. Okay, so that's what I have now. So I have x to the 5th minus 2x to the 5th equals 24. These are like terms. 1x to the 5th minus 2x to the 5th is negative 1x to the 5th equals 24. I can divide both sides by negative 1. And that would give me negative 24. And then to get x by itself here, you would have to take a 5th root. So x equals the 5th root of negative 24. And that's a decimal. Okay, the way I could do that on a calculator. Sorry. Go to math, go down to option 5, the 5th root of negative 24. Negative 1.888. So that was one answer, and That's the other answer. 888. And so that's what the calculus tells me. That was a really, really hard question. Okay. So it said find the x values where you would get vertical tangent lines. So we don't have to stick those back into the original function. Okay. So these are the two answers. Alright guys, here's another video finishing this problem out. I told you that these are the 2 points on the graph where we have vertical tangent lines. Kind of lied to you for a second. So if we go back to the Desmos graphing calculator, all right, even though that the calculus tells me that x equals 0 is an answer, this isn't really an answer. And here's why it's not an answer. To be able to have a tangent line, all right, to have a tangent line, the graph has to be defined there. At that x value. So if we look at the Desmos graph, okay, it actually looks like we have a vertical asymptote at x equals 0. So like if I go back to the original function, and the original function said xy squared minus x cubed y equals 6. Okay, let me go back to my screenshot here. Okay, if I plug in an x value of 0 here, I would get 0 times y squared minus 0 cubed times y equals 6. Well, if I simplify this, 0 times y squared is 0. 0 cubed is 0 times y would still be 0. That's not true. Okay, 0 does not equal 6. So that means 0 is not defined for the relation. And since 0 is not actually a point on the graph here on Desmos, okay, x values get close to 0, but x can't ever actually equal 0. And because it can't, that means that there's not actually a tangent line here. Okay, there's only one vertical tangent line, and it's only at this x value. So even though the calculus told us there were 2 answers, there's only really one answer, the 5th root of negative 24. Okay. If I plug in this number into the function right here, if I put those in for x, I can figure out what the y value of that point is. So if I plug this x value back into the relation, okay, right here, if I plug that value in, then I would get a y value out. So the function does have to be defined there for it to have a vertical tangent line. So x equals 0, this one right here in red, that's actually not a vertical tangent line. This is the only vertical tangent line at negative 1.888. Sorry about that.